Hello and welcome to the EEPROM 9. Today we have a really weird bit of kit. It is apparently a colour video copy processor, a CP15E. I never even knew these things existed until I came across it. It's a bit busted and smashed and whatnot. But what this thing seems to do is it basically takes a video input and prints it out to paper. Why such a thing exists has me completely and utterly stumped. But it comes with paper, which isn't really paper, it's more of a sort of plastic stuff. It seems to use some form of thermal printer and contains a lot of the sort of electronics you'd find inside a video recorder, so it's interesting on a pure curiosity spectrum. You know, you've got a lot of stuff. I mean, when I first saw this, I thought it was a computer. I looked round the back, oh, it's not a computer. It must be some kind of CCTV DVR type thing. I could see why the engineering department would want to use that, because they have cameras on various bits of equipment for monitoring close-up work. You know, little camera microscopes and that. And they do exist in there. But no, what we have is basically a thing that prints images. Now this is part of the print thing, and what it seems to be is you've got yellow, you've got clear, you've got a bit of black, you've got a sort of bluey colour, and then there's pink. So we have an interesting little thing. So this is obviously for the actual printing of the colour. There's the yellow and the pink again. Just a little cartridge that goes in there. I don't know whether it's ink, but it seems to use a thermal printer. And on the front we've got a few like basic controls like print, memory, monitor, frame, feed, print counter. And there might be a little LED display in there or something. We've got a power switch, we've got a few settings here. But yeah, it does look like it links to an external monitor, which would be a classic sort of probably 90cc TV thing. Besides, there's really dump all. We're missing a cover that will go over here. This is where I think the printed ones will come out. It looks a bit like a 5 1/4 inch floppy disk bay, if you ask me. Unfortunately, it's not, because that would make it more interesting. And then on the back, we really don't have much. We have some sort of remote input. Yeah, I've had the screws out of this. We got our what's it called? The kettle connector. It does have a proper name, but we just refer to it as the kettle lead. We have S-video, because we totally use that in the UK. To be honest, you never ever see it in the UK. And we have good old composite video. But no SCART. Weird. So let's liberate the cover off this thing. And dump it over there and give you a nice internal overview. And as we can see, sorry about the more crapper lighting, but there's not a lot I can do about it. My lighting system won't go much further down than that. So we have a fan over what is probably the thermal print head, which is also on a spring, so it can sort of adjust to the paper. Fan to keep it cool. This is part of the doohickey thing, whatever you call it. It's also got video recorder tape drive mechanism right here, which is an interesting note actually. In the front here we have the control panel. Under here we have the control panel as well. This is an entire print mechanism. Half this thing is a printer. Then we get to what looks to be some kind of motor driver board, although I have not confirmed this. Good old switch mode PSU, which if we pull out the way, underneath is basically the brains of the operation. We'll try and get all these boards liberated so we can look at them in more detail. Then we have the analog processing section. There's actually a board underneath which is only about half populated, But this one seems to have all the major stuff like the delay line, memory, it's got a shielded section, it's got comb, I don't know what that means. And that's really about it. You can sort of get a view in there like that, but it's going to be pretty dark and my torch is eluding me. As suspected, there are LED indicators and whatnot, and including a 7seg display. We've also got a better look at the print mechanism, which gives a more in-depth view at the internal mechanism. And of course the switchboard, which really is nothing special. So let's take a look at the switch mode PSU. At first glance there's nothing particularly remarkable about it, but there's a few interesting things I would like to note that are actually interesting. First off, we have a little section there where a ceramic resistor is connected into another part of the case, which is probably some sort of load resistor. Maybe this is one of those power supplies that requires there to be a load for it to start. You get some, otherwise they can be unstable. It could be one of those topologies. We got our opto-isolar feedback. The capacitors are good, genuine brands. I think it's all of them are that, and yes they are, by the looks of it. In the back here though, we have this. Now for those of you who don't know what that is, it's basically a mains filter. And it just smooths out the mains so it's not such a horrible mess that it could potentially interfere with equipment. Then of course you go to your usual standard filtration you see in all but the very worst of power supplies. And then of course we've got this little lug here. Now some of you will be thinking, what the hell's this for? This is basically an extra external grounding point. For the countries that have a very dubious sense of what earth mains is, that's why that exists. And trust me, there are plenty of countries which have absolutely woeful power systems that are just damn right dangerous. There's nothing coming through too much as a date code yet, so we're not entirely sure, but this is probably going to be 90s equipment, looking at the general design of things internally. 90s video recorder styled equipment. There's also a relay on the output, which is not too common on switch mode power supplies. They don't often have relays on the output. Usually the relays are part of high voltage logic or something. So an interesting thing to note as well. I'm not quite sure why that's there. Could be part of the protection mechanism. It shorts out, it cuts off the relay and cuts the power to the output. Could be something like that. Now we get into the detail of the board. Note all the capacitors on this board are Rubicon. Thumbs up. The first chip we will look at is the CXA1228S, which is a Ntsc PAL decoder. Now it's got a crystal right next to it, but the crystal is pretty much, it's either got a weird code to its frequency or it's just not printed on it. But it will probably be at one of the PAL carrier ranges, bearing in mind we live in the UK, so probably going to be PAL. We have the delay line memory here with a date code of 9302. We finally have a date for this thing. It's probably 93 to 94 vintage. So this thing's over 20 years old. The next chip, if we can get the light over it so you can actually bloody see what it is a CXA1229P, which is an Ntsc PAL encoder. So it not only decodes, but it can recode it. So this thing can potentially superimpose images upon it. But that could explain the functionality, whereas you've got an in on the both the S-video and composite, and an out on the S-video and composite. The next two chips, these two are the same, are the NJM2265L. And these are dual comparators. Yep, just your bog standard dual comparator, or am I looking at the wrong data sheet? No, I'm looking at the wrong data sheet. Sorry, that's my bad. That is the dual comparator. That's the one we mean. I was looking at the wrong data sheet. There's so many chips on here that you can't memorise what they all are. Sorry about that mistake. That's the dual comparator chip. Now that could be used as an amplifier, a voltage ref. There are a number of things. We've also got a number of test points and a few little labellings like 1, 2, whatever, 32 and whatnot on pins and stuff. 1, 8. Good jazz like that. The next bit is these two, which is the NJM2265L, and these are 3 input video superimposers with 6 dBm amplifier. So what's that in actually English rather than video gobbledygook? Well, basically what it is a video switcher which has a amplifier with a gain of 6 dB, which is a fairly nice gain actually. That's quite a nice thing. Nothing like good old technical difficulties. Memory card runs out and then good old shit. That's gonna make getting to uni tomorrow a complete bitch. Back on to the main subject. Yeah, nothing like good old technical difficulties where, you know, you try and transfer your data through your laptop and your laptop craps out on you and Windows wants to update and, yeah. Piece of shit. Where were we? We were looking at these, which were the superimposed dB output buffer doohickeys. Well, now we're on to the next one, which is a NJM2245L, which is pretty much the same thing, just but only labelled 3 input video switch with 6 dB amplifier. That'll be for the S video. Pretty much the same thing, probably slightly less glorified because it doesn't have the overlay doohickey thing superimposed. What you would call it. The next one is this little bugger, which was really difficult to read these things. We need to cut out our little tray. Oh yeah, you got to like the absolute complete high-techness of my recording. It's done in the most bloody rudimentary way possible. Production quality, what's that? And this is an LA7222, and this thing is a 2-channel, 2-position AV switch, usually for VCR audio use. You can see why I instantly recognise this sort of circuitry, can't you? Combine that with things like the delay line memory, which I will link to Mike's Electric Stuff video of that, because that video is absolutely bloody awesome, and he actually ends up putting bloody ASCII text through it in RS232. The next 2 chips are under the shield, so bear with me while I pull it off. I don't know why I put it back on. A bit of Bishop PCTM style, we'll probably stab ourselves. There we go, it'll almost knock the camera off. Let's just break our camera as well. There's 2 in here. One there, one there. And these are Sony. You'll notice there's a lot of Sony parts on this. This is pretty much a Sony device rather than a Mitsubishi. CXL5505M, and I don't know if there's a /P. No, these are the 05P variants, not the M, because you've got M and P. And what these are CMOS CCD H1 delay line for PAL. So what does that mean? They're basically the delay line controllers, probably 1 chip for each end of the delay line. We might actually show you inside the delay line because they're quite interesting. I tried doing a bit of removing, but it wasn't too successful. As you can see, I've melted bits of the cover. What you've got is it's a sort of a got this strange texture on the external as part of damping to get a clean signal through it, whereas the edges are rather smooth. These are basically little dampers to stop it spraying out and keep it in a straight line like a laser, although how effective that is I don't know. And interestingly, both transducers are on the same corner. Usually you'll find one up here and one down the bottom, but in this case that is not the case. I would say bear with me and I'll get another one I have out, but I know where it is and I know it's buried pretty well, so I'm not going to get another one out to compare this with. But yeah, I find these things personally quite interesting. But then they're one of those odd technologies, and maybe I'll do something similar to like Mike did, where I actually try and put some ASCII data down it. But I need myself a pulse generator or function generator or something like that first. Although I could get away with maybe using RS-232. Oh well. An experiment for a later video. But I personally find these things rather fascinating. Next board is unfortunately not as interesting. First off, we have this undisclosed mysterious chip which has a crystal to it, which tells me it's something to do with video processing. Much like the mysterious chip on the other board, which I've since removed. That's a signal processor. We have a whole load of basically 7-4 logic. We also have 7824. I'll double check if that's a voltage regulator. We've got 74LS221. We've got a 4053. We got another 4053 there. We got a 5153. And then we have something a little more interesting, a 74HC74. So we have a dual knot flip-flop there. So we'll definitely be using that for something. But the other ones, we'll probably pull them off and find a use for them. So yeah, that's pretty much these boards done with. I'm just going to double check and report back. Well, I was completely wrong. In fact, it's to do with the CRT timing for the electron beam scanning. You know, it controls things like the blanking and whatnot. That was an interesting find, bearing in mind there's no CRT inside this device, but yeah, fascinating! We have ourselves another interesting circuit board. We have surprise chips underneath. So, bear with me while I just go and get the data sheets for as many of these as possible so we can find out what all this does. Oh look, we got aliasing or whatever it's called. Look at that flicker. Okay, after some data sheet searching, I realise I don't have a pointer. We have come across to the conclusion of what these are. This is some kind of custom ASIC by Mitsubishi. So yes, they did actually make their own parts for this thing. Was it Mitsubishi that made this? I forget. Yes, it was. So yeah, they did do their own parts. They just used a lot of Sony parts. See, these companies couldn't survive without each other, but they all use each other's parts. Ironically, they're also competing. So this is some kind of ASIC processor because it actually has RAM. This, I'm not entirely sure. I can't tell you what that is, but a lot of pins go to it, so it could be some kind of I/O controller. I mean, even though all the I/O's down, the I/O is nearer to it, as you can see when we flip the board over. This might actually be the Printhead controller, because if you look, there's the main, what goes to the printhead, and look what's below it. So it could be I/O printhead controller. These are RAM chips that look to it. These are DRAM chips, as can be seen here. If the camera knew how to focus. Come on. Focus. Focus! Oh, you useless pile of turd. Hitting the button seems to force it to focus, which is good. But yeah, looking at that, they look like they're 256K. I don't know if that's bytes or bits. These things are not always entirely clear, and this is probably going to be the controller, especially when you look at the pins going into this thing. Here, this is a 8-bit high-speed CMOS static RAM, SRAM, so we've got DRAM and SRAM on this board. We've also got another similar chip, but it's not bringing up anything on the data sheet. wise, but it will pretty much be the same thing. It's just got a slightly different part number. And so this one, looking at it, I would say it's probably about 256 kilobit again, but once again, they're never particularly clear. 32,768 words. You know, a word means anything above 8 bits. You know, 16-bit, word. 32-bit, word. Yeah, doesn't really tell me the memory capacity. If maybe you said bits there, we could work with that. Maybe it's 32k. Could be, looking at that value. Yeah, let's say this is 32k, looking at that value on the screen there. That makes sense. I'd have to do the math to work it out completely, but we're going to say it's 32k. This is an M50734SP, and it is a microprocessor, well, microcontroller. Only it doesn't have its own RAM and ROM built in. The wiki gives a good sort of thing, because it's basically an enhanced 6502 processor. Yay! We could probably run this on a BBC Micro. It has 24 input-output lines, 4 analog to digital converters, that's where they live for the video stuff. A universal asynchronous receiver transmitter, so it doesn't require a sync on the transmitter. High-speed inter-processor link, I'm guessing that's to communicate with other processors. Chip under here. Hey, is that the Rogers or the ambulance? Don't know. It's the Rogers! They just drove past my house. Power down sleep mode, well, everything has that. And extended memory addressing. But of course, this is just a beam brain, so it doesn't have much to do. Also, over here we have your good old 27C 512 EEPROM. So we've got a 512K EEPROM, that's kilobits, not kilobytes. We have a crystal with heat shrink that looks like it's a 20 megahertz crystal. Whole ton of jelly bean logic things. One of these mysterious chips has reared its ugly head again. And, more interestingly, an LM324. Yay! Quad op amps. We like those. They're handy. They're great for beam robots. And we also have a 74 ALS 373N. I seem to remember replacing a whole load of those in the IBM 5150. Only they're all LS in that. But yeah, interesting nonetheless. That's the brains of the operation. That's awesome. And the camera card's about to run out, so we're just going to let it ramble out and give you a nice view. Loads of passives. A lot of dip stuff because more date codes on these ships. The last really interesting circuit board before we dive into the mechanics. Yeah, there's still more of this to go. This is quite an interesting teardown actually. There's quite a lot in it. This little bugger is basically a dual comparator. This one is a quad comparator. This one is a, you can find all these data sheets really easy. C393C. This one is a UPC339C. Interesting, it's got the micro symbol there for U, for UF. You know, like you get in the caps. Look, there it is there. Yay! And these are all pretty much the same chip. Even the big one with the heatsink, only these are the N variants. These are BA6209Ns, and this is just without the N. And what these are basically motor drivers. More specifically, if we can find them. No. Oh yeah, this is a Hex Inverter. This one is... forgot about this one. This one is a Hex Inverter. That means it's basically got 6 NOT gates in it. To sum it up nice and simple. And this one's the motor driver, which can do, there we go, the applications. VCRs, cassette tape recorders, you know, usual things. Power transistors can handle large current, 1.6 amp maximally. Is that even a word? Come on. But yeah, motor driver board. Not too much on it, but quite interesting nonetheless. We've also got at least one stepper motor in the design of this thing, and we may have another one here as well, so we need to hunt those out and remove them. But yeah, little motorboard, not much to it, quite interesting, and we've even got some vari-cap adjustments, so if you're into your radio you can pillage those and use those in your ham radio. We've also got some flame resistant resistors as well, which are the ceramic kind. Power supply, ballast resistor, 4.7 kiloohms. I'm not sure on the wattage because of this stupid metal shield which attaches it to the chassis. As a last part is the little overview of the mechanics. I'm not much of a mechanical engineer, so there's not really anything of interest here for me. This is all pretty much destined to go back in the bin, so yeah. I hope you enjoyed that teardown, and thanks for watching. The keepy pile I've got, I might have to reduce it a bit. I'll probably desolder a few components and chuck some of the boards back in here. The thing worth noting with this is, among the data line that gives the printer the ability, the thermal head, to print off the image, the other loom goes to the power supply. There's a direct matching connector for this, and that's where it came out of. So yeah, this thing has its own power supply. It has its own separate power supply part, which is quite interesting rather than going through this. So this is obviously quite a high current device, more so than what you could stick down the spindly little thin data lines.